Mr. Ward, like, Mr. Ward has been.
I have actually damaged it.
So Mr. Ward for months now has been trying to rip it out. Now it just dawned on us. You close it.
Okay, hey. Okay. Today. Okay, hey, we have to talk about a few properties here about logarithms. I want to make sure that we know how to cover them. The goal today is after we get through these properties, we're going to do a few examples today. Okay? Alright. So, I want to talk about a few examples to make sure that we know how to cover it. Pretty straightforward. In fact, I'm going to just pull a couple problems from your book so they'll look almost identical to your actual homework today. So yeah, I'll tell you which problem. Okay, but I'm just going to pull a couple, but we need to get through the properties first. I started with 2 yesterday. Let's review those 2 right now, and then we can get to the 2 new ones. Alright, here we go. Okay, so here's our properties I want to cover.
You are Al.
Alright. Okay, let's put the computers away and stuff. All that good stuff. Thanks. Alright, so, okay.
Oh, yeah.
Now, hey, first property. This is one we talked about yesterday.
I am.
Okay, first example.
Hey, Web. Hey, Web.
Alright. First example we talked about.
It's one.
Alright. So we talked about this yesterday. This number is number 1. Now this is the first property. This is what we're trying to find. How we know that?
Because it's the same thing.
Yeah. It's what you're trying to do is you're trying to take the base, which is 8, put it to this power, and then ends up here. So this is what we were actually trying to find. And the idea is why it's 1 is that the 8 over here has 1, and since the bases are the same, you can set the x and the 1 equal to each other, so the x is 1. And that's what they're trying to find here. They're actually trying to find the answer for a logarithm.
Isn't that kind of common sense, though?
Yeah, it's pretty straightforward once you see it. Okay. Hey,
Tori.
please talk.
Lesson, please. If you look, are all properties of common sense not the lunch disrupting the lesson? Shh. Come on, guys.
Hey, can we stop talking, please? Okay. All right. But again, here's my shortcut for how we figure this out. You're trying to figure out what power you put on the base here that makes this number. That's my shortcut. That's just how I want you to remember how to do this problem, so you don't have to think about, okay, I have to put it in the circle method, convert it back, and then figure it out. You're trying to figure out what do you put on this 8 to make it this number. That's the easiest way I can explain it. Now, the next example. So the next one, this is the next property we talked about. It was when you take a log of some number, I'll just use 9, and they have a 1 sitting here. The answer that we talked about yesterday, this was going to be a 0.
Why?
Okay, because the power you're going to put on a 9 to make it 1 has to be 0. 9 to the 0 power is 1.
Go say.
Okay, now, here's why. The easiest way to explain, other than showing this, that when you do the little circle method to actually bring it back to the 1 here, you're doing 9 to some mystery power, which we know is 0, equals 1. And this explains, because the only way that this can work is changing this to be 9 to the 0, which means you'd have to know that it's a 0 anyways, and then you can set the powers equal to each other. Anything to a 0 power is the number 1. Those are the 2 properties we talked about yesterday, but the trick was to remember what these answers are. Okay? Make sense? Alright. New stuff today. Shh. Hey, new stuff here.
Oh, it's all 3 of you.
Okay. Alright, next example. Log. Let's go log of 10 to the 3. Okay, now, this problem, there's 2 reasons why I put this problem on the board. There's 2 reasons. Number 1, that technically, I don't need to have the 10 in the base. Anytime, and this is true for your calculators, anytime you actually just write log, it's actually assumed that you actually have a 10 sitting there. So really, this is also the same thing written down. So this is something that I also want to talk about. Logs are typically base 10 unless written otherwise. It's like in math where you assume everything's a 1 with power, or exponents, have ones or powers. Okay. Now, on this particular problem, since we have a base 10 and 10 here, the answer to this problem is you're trying to figure out what power you put on a 10 to make 10 to the third. Well, it's pretty obvious. The answer has to be 3. Because you're trying to figure out what do you put on the 10 on the base that makes 10 to the third power. It's the 3. So here's the trick. This is one of the properties we're eventually going to talk about Thursday. So this is one of the properties we're going to talk about Thursday. In fact, let me, I'll leave it on the board here. All right. So here's the main property you're going to need to learn. That when you have this, the 3 can actually drop out front. This is actually called the power rule for logarithms.
What?
That you can drop the power on the actual number that's here out front.
Is it 3 log 10, I bet?
So 3
So 3
log
times log
10 of
10,
10, which is
It
3
equals
log,
three.
which is 3 log 10.
It equals
And
3.
but the idea is that this thing we just talked about a little bit ago, that it was this property. This is the one. This is what I just talked about a little bit ago, which is 1. So this part right here is a 1 times 3, which turns out to be 3. So that's the reason why it works. But the problem is we're technically not supposed to see that property yet. That property is actually coming up in later sections. It explains why this works. So I need to show you that.
Did you do your history?
But that's going to be the one that we're gonna look at possibly Thursday.
You know what, make it Monday.
You know, we might have 2 hours late on Thursday, so we wouldn't have a whole period of wrap
Hey,
head around.
hey, let's go. Okay. All right. Last property we have to talk about is when they put a log in an actual power. So let me go to the last property that I want to cover. Then we can talk about the last few examples that I have taken. All right, here we go.
I just
4 log 4 of 6.
Whoa.
What the?
That's crazy.
Okay.
Whoa. Is that in the power?
All right. What? Yeah. This
like I don't know how
log.
to
You can't do
use
that.
property.
This log is actually in the power
It's 6.
of the 4. Yeah, the answer is 6. Now, let's talk about why this works. The whole purpose here, why we get this, is that the bases, so,
You make your 4s kind of weird.
By Thursday.
Why is that?
alright, so hey, the bases
I got mine too. We'll probably-
are the same. So how I think of it is that the bases just cancel each other out, and you're left with the 6. This is just how I see it. No matter what sitting
So
there.
what if
Even
it's like a
Even
5?
if this was like a 5 to the second power or something like that,
That's like
that you'd still leave it. It would still be 6 squared. That'd be the
Which is 36.
right? All right.
How about 36?
Now,
What happens if the 4 is a 5?
okay. Now we can't do that.
We can't
So
do that.
now, yeah. So if
Will we be able to do that?
Never.
you won't have one of those.
Never.
So if
Can you do that?
you just type it in the calculator, that's all you can do.
What if you don't have a calculator?
I tried to figure out my hands.
Here, I'll
Can you
solve
show
it,
us?
Mr. Ward.
We did ours.
I'll solve it.
This won't work out nice and brief, but all right. So let's say this is the problem. So if you didn't hear Justin,
2,325 points.
so if you didn't hear Justin, what he was talking about is what happens when the bases
I have different.
when the bases are different.
You do 4 to the log 8.
Yeah, you just have to. You actually just have to type this in your power. You have to actually figure out what the log base 5 of 8 is, and then that number is the power on your 4. Now, what I can tell you right now is it's between, like I'm trying to figure out what power I put on a 5 to make 8.
5.97 is the answer.
Yeah, it's 1 point something.
1.9.
5 to the 1 is 5.
1.29.
So, stop talking.
1.29.
Drive me nuts.
So how would you actually go about doing that
Alright.
if you didn't have a calculator?
So, because this is what I do. I guess like what this decimal is roughly.
0.29.
And whatever that number is, 1.29, whatever it is, that number is the power that you're putting up here.
Makes sense.
And then you'd have to figure out that number. So it's between 4 and 16. It's probably closer to 4. So like there's not an easy way to do it other than guesstimating it. But the property that I want you to know from this is this, that when they have the same base here and here,
X amount.
yeah, they cross out, so whatever comes after it, that's your answer.
You cross multiply.
All right. Questions, comments with the main properties? All right. All right. So stop. That's the main part. Now we got to do a couple examples here.
You said that you're gonna look at the nothing is more than 14 years.
I'll look it up again.
I don't understand how the log cancels out. It's because it's like the exponent.
No.
Yes.
No, not in.
So how they actually explain it, they put a variable over here, and then they do like a circle method, and they set up a log when they do the circle method, because right now this is exponential.
Yours.
So it's log base 3 of x, right? Log base 3 of x equals the power.
Yes.
Oh.
Make a lot of money.
And the only way this works is if those are the same number. So that explains why if you actually do the circle method, why it actually is 11.
Will you leave that up there so I can write it?
Okay.
So,
All right.
we're done doing it, right?
No.
No.
We're doing more notes. More talking, more notes I'm going to go through. All right.
I just thought that was.
That's yeah, but like some of them don't deal with bases.
All right. So let's do an example of one of the problems that we're going to have you do. I'm pulling this one directly from your book just so you can see it. This is one that they ask us to find the answer without a calculator.
Will this happen to be a homework problem?
Could be. Could. Maybe. Maybe. All right. It is problem number 31. If you want to know, because these are problems out of the book that I want you to kind of know. All right. Now, why I'm pulling this problem? They want you to figure out the answer without a calculator. So, what I'm going to do is I'm going to try to write this problem down where you can use the properties we just learned a little bit ago to help us simplify it. Okay, so on this one, when you have a radical, that is the same thing as putting a fraction in the power. So like 2 with the square root, a radical on it, is the half power. Now how I know that? The index number on this radical is actually a 2.
And then you do the
And
circle.
that's the number that you'd put on the bottom of the fraction. So if it was a third root, you put a 1/3 on it. So this is 2 to the half, and we still have the log base 2 out front. And then the trick is, we're going to move this up. So we're going to move this 2 to the top of the fraction bar. So now it becomes this. It becomes 2 to the negative half, because the negative half will move it to the bottom of a fraction and make it a radical. Like what you're seeing here, I'm progressing. And now that we get down to this part, you can see that this number and this number are the same. So what we're left with, and this is the problem we just talked about a little bit ago, your answer is going to be the half, the negative half.
Well,
Because the half could technically, the negative half could drop out front, and then the log base 2 of 2 is 1. So that was the first property we talked about today. So the answer is the actual power. Because if you can make these numbers the same, the answer is going to be the power that's on it. But if the numbers are different, then you have to do the little circle method and actually do a calculation of it. Usually the numbers always work out to be the same. Let me show you a different one here. One of the problems that I saw in the book that didn't have the exact same number was, okay, it was this.
I'm so hungry.
Okay, here's the one that I saw in the book.
What if you cut off?
Okay, this is what they had. Well, it's a very easy problem if you think about it. If you don't want to change it back to the circle method, you're trying to figure out what power you put on a 3 that makes 27. Okay, that's what you're trying to do. Now, most people know it's 3, but how I can do it with that right there is I can make the 27 3 to the 3rd power. That's what 27 is. And since these numbers match, your answer is the power. That's what we're doing over here. The answer is just the power. When the base and that other number actually match. So that's kind of the trick for how you do these problems. Okay, that I think is the middle few problems, 2 or 3 problems you have. All right.
External auditory meatus.
Quit it.
The meetings.
It is the
Quit.
meanest.
Is this gonna be another
Yes, it is.
homework
Hey,
problem?
let's stop. So, okay, next one. All right. This is one of my last examples today to see if you guys can figure this out. This is something we haven't seen yet, and I want to make sure you know it.
This one happened to be a homework
What number
problem.
is
What
this?
is it? I'm gonna put it.
This is problem number 90.
90.
Number 90.
OMG, that's a big number, Mr. Warren.
Okay, problem number 90. Okay, so what this is the natural log. It's the L of n. It's kind of like a log, but the base here on this it's basically a logarithm. Bless you. Bless you again. All right, it's a normal log, but it's a base e. So this is actually the same problem written out. These are the same thing to me. It's just the L of n means log of the e, the natural
So
number.
they can cancel out.
So yeah, so
So it's just
these would
7.
cancel out. So your answer is just 7. because the base, so it's the same problems, it's just using a different form of a logarithm. If they do that for tens, the same idea. You know, for log of 10, of, 10 to the 7th power.
7.
Okay, it's 7 because
It's 7.
the way the book will write it, they'll write it like this. This is the way the book will write that problem. Because on a log, you don't need to put a 10, it's already assumed. It's already assumed it's 10. So it's the same idea with this, that we can actually change it to put a 10 there, and then you can go from there.
Why do you assume it's a 10?
It's just one of those things,
Base
everything's
10
base
log.
10, because this stuff originally was created for doing like scientific notation when you do powers of 10s. That's what it was originally created for.
Why is it
And so they just, as default, they just use 10s for the base number. 10 to some power, you can move the decimals.
Why wouldn't
That was
you do
original.
like 1?
See, that's what I would have done. I would have done like 1 or 2, something that's like more normal for us. But
10 is kind of a big
10's
number.
easy because anything with powers of 10s is probably the easiest number to calculate. Everything else needs like really strong like calculators.
What
to
about
actually
1?
figure. 1, yeah, well, I guess 1.
You don't need a very strong calculator to calculate
But
1 to the 11th
but the idea,
power.
if it was a 1, same idea. You can just move the powers again.
Right,
You
but
can
then
move
it would be
decimals.
easier.
So same concept.
But
10s and 1s.
smaller number.
So still a multiple of 10 though. So.
Yeah, Justin.
Still, because it's just like the decimal can just move. It's the same.
Right, but then you move it.
All right, here's your homework today.
Well, for sure.
All right, homework. This is due Thursday, no matter if we have school or tomorrow or not. So you will. So I'm warning you. You do need to take your book home. Like you have to take it or take a picture of it tonight, so you have it and you can actually look at it. So here we go. Here's your homework. Page 410. Numbers. Now this, I'm going to jump around a little bit because I didn't pick necessarily in order. All right, here we go. Problem number 4, problem number 8, 10, 13, 23, 26, 30, 41, and 82 through 98. And these are the column going down. Now, what I mean by this part right here, the 82 through 98, it looks like, oh my gosh, we have to do like 20 problems. No, there's like 5 problems that are stacked on top of each other. So you just do the column that's from 82 to 98 straight down. There's like 5 problems there.
So there's a ton.
So, there you
I mean,
go.
there's 5. There isn't there like 7?
There's 5. There's exactly 5 there. Okay? Alright, but here's your problems. The first couple, they don't actually have you solving anything. All you're doing is you're taking an exponential, changing to logarithmic. These next few, you're taking a logarithmic problem, changing to exponential, going backwards. Then the later ones now, these are ones you have to solve like I've been doing on the board, where you actually have to find the answer. Same with the last one. Use your properties. You, in theory, you will not need a calculator.
I will probably use one.
Okay, you won't need it. Because everything is a simple property, you'll cancel, you'll drop powers out. This homework is super simple, but if you actually start working on it. Okay, don't wait till Wednesday night.
Then you'll
You're at
forget how
home,
to
you're
do
gonna
it,
forget how
right?
to do it.
Yeah.
Tomorrow night.
We're gonna have all day tomorrow to do it. I'll have 8 hours. I'll train.
All right, there you go.
Only 8? You're only gonna be ready 8 hours.
Yeah, I'm only 8 hours every day. I go